going to be going over transformations on this lesson. So I recommend that you have your paper in front of you with pencil and your laptop open so that you can look at Desmos. You can, of course, be full screen on Desmos. I would like you to make sure that you are typing and writing everything that I'm doing at the same time. All right, so we're going to talk about number one and question number one in the transformation, and we have the equation f of x. Now, typically that's called our parent function. Parent function is not always going to be f of x is equal to x. It could be, we could be starting from another function that has some other transformations already done to it. But typically, if we mention the parent function, we are looking at f of x is equal to x. So if I type f of x is equal to x, okay, that gives us this equation and this line, which is going to give us that table. Now I'm going to go ahead and create the table just so that we can talk about that table. I'm going to take out the -1, and I'm going to take out the 1, and then I'm going to write 4, just so that our table matches exactly what we have on our graph for f of x and for our table here for those values. And it has it graphed for you already. As you notice, it's going through the origin, okay? Now, we're going to talk about our transform function, g of x. That's this table right here. We got to fill out that table. So I'm not going to delete my parent function because I'm going to type exactly what I have here. So f of x is equal to f of x plus 4. So let's talk about the, let me make my parent function line black. So I'm going to go here just so that it's easier to see and visualize. All right, so now as you can see, let's talk about some of the different things that happen in terms of the y-intercept. So the y-intercept was originally 4, or originally 0. It is now up there at 4. And our 0 of the original f of x graph is at 0. It is now at negative. So let's zoom in so you can see those values. So that value there is 4, negative 4. So we are now at a value of negative 4. Now let's talk g of 4. So remember, g of 4, there's a couple ways. The easiest way to handle this is to go ahead and convert this. We're converting this second one into a table. So I'm going to go to the edit, and then I'm going to convert that to a table. So if you notice, it's got our inputs, our x values, and then our outputs, our g of x values out here. I'm going to go ahead and make our x value, I'm going to change it, and I'm going to put 4. So that gives me my output of 8. Now let's talk about what that means. To remind you, since our parent function is just x, when we say f of x, that means x plus 4, okay? Now let's say it's x, and I'm going to, no, never mind, I'm not going to do that. I'm going to skip that, what I was going to say. I'm going to go ahead and backtrack. Now let's go ahead and graph it because we want to get that extra practice of graphing. I now have a y-intercept of 0, 4. And I have a same slope, so that means I'm going up 1, right 1, up 1, right 1, up 1, right 1, down, back 1, down, back 1. All right, I got more than enough to graph. Now, just to remind you, or rather just to mention this, what's going to be a lesson that's coming up too right after this, is these two lines have the same slope. The slope has not been changed, so they are parallel lines. Now we're going to describe the transformation. What's different? We shifted g of x, or rather we shifted f of x to g of x up 4 units. You can also say vertically up. Okay? Now we've answered the first question. Let's talk about the second question. So just like we did the first one, I'm going to take out my g of x equation. But instead, the difference between this one, now we're shifting down. We also didn't do our table, but that's okay. All we're doing is plugging that in. So that would, number 1, that -2 plus 4 would give me 2. 0 plus 4 would give me 4. There's our y-intercept, 0, 4. 2 plus 4 is going to give me 6. 4 plus 4 is 8. Okay, now go ahead. We'll go ahead and continue number 2. So now, instead of being plus 4, we're going to subtract 2. And as you can see, that shifted our graph how am I go over? I'm trying to make it smaller. Oh well, it's not going smaller. Down instead of up. So now we have a y-intercept of -2. So where x is 0, we have a y-intercept of -2. Think about this. -2 minus 2 is going to give me -4. 2 minus 2 is going to give me 0. And then 4 minus 2 is going to give me 2. So if we convert this to table, okay, as you can see, there's the -2, 4. There's the 0, -2. The 2, 0. We'll type in the 4, 2. And let's go ahead and finish. We're going to graph. So we are down here at -2. And this one also has a rise of 1 and a run of 1. And we can go ahead and connect those dots. Now let's answer some of these questions. So our y-intercept now is 0 at -2. And our g, our 0 of the graph, is now over at +2 instead of at 0. Okay. Now there's some interesting things that happen in between the zeros of the graph between 1 and 2. If you noticed, our y-intercept went up, so our y-intercept went positive, and our 0 of the graph went negative. Okay. And here, we started at 0, we went down for the y-intercept, and then our 0 of the graph went positive. So that was an interesting transformation, and we're going to talk about that in just a moment to see what happened there. Now let's talk about where we have -1, g of -1. We already have that right here. So we know that value is going to be -3. So we're going to talk about the transformation. We vertically shifted down 2 units. And that's pretty much it for that type of transformation. That's what we call a vertical transformation. You're either shifting up or down. Now, number 3 is unique. So let's talk about number 3. Because if you notice, so 1 and 2 we're either adding or subtracting to the parent function. So that's x plus 2 or x minus 2, and we shifted vertically up or vertically down. Number 3, if we notice, we're multiplying on the parent function. So if you notice, I'm going to type this in. So g of x equals 3 f of x. I'm not adding or subtracting. Now, notice this new line here is not parallel. It's intersecting the original graph. So it has the same y-intercept as 0. But if you notice, our graph is more steep. If I convert the second equation or the second function to a table, we have -2 is now 6 for our output, +2 or -6, and then +2 is 6. And then let's type 4. 4 is going to give me 12. So if I go down here and graph, so we're going to plot 2, -6. We're going to plot 0, 0, and we're going to plot 2, 6. And we can't plot the other graph, but that's okay. We only really need 2 points to graph the slope of the line. Now, we notice our graph got more steep. And if we think about this, we take that -2 and we're multiplying it by 3. That will give us -6. 0 times 3 would give us 0. 2 times 3 gives us 6. 3 times 4 gives us 12. So we have stretched our graph. We made it more steep. So the y-intercept is same. We didn't change the y-intercept. So the y-intercept is still 0. The 0 of the graph is also still 0. Now let's find g of 5, because if I go here to g of 5, it's going to be out of my graph. So I'm going to go ahead on my table and type 5 for the x value, and that gives me 15. If you think about that, what that means is I'm saying g of x is equal to 3 times our x value. Our x value is 5. 3 times 5 is going to give us that 15. So this transformation that we did here is we vertically vertically, I can't spell, vertically stretched. That means the y values got steeper by scale factor of 3. And if you also think about it, we're talking about stretch, we're getting steeper because we're multiplying by a number larger than 1. Now, if we look at number 4, we have a scale factor of 1/2. So now, instead of 3, we have 1/2, which is less steep. So we're still having those values. Let's go ahead and convert to table so that we can look at our table values. So when -2, we've got -1. 0 is still 0. We got 2, we got 1. And when we got 4, let's go ahead and put 4. We got 2. So think about our values are like compressed versus stretched that we did on number 3. Okay, so we went from 1 to 0. So here, when x was 2, we went to 2. But here, now we went from 2 to 1. We went from 4 to 4, 4 to 2. So our values got, our y values, our output got halved. So now we still have the same y-intercept, but now we're less steep. We have our slope is now 1/2. It's half of the steep of the original one. So we compressed, or more flat, by scale factor of 1/2. And now let's find g of 8. G of 8, that gives us 4. That'd be 1/2 times 8. Half of 8 is 4. 0 of the graph is 0. 0 of y-intercept is also 0. All right, I'm going to go ahead and stop this video, and then you can go on to the next video and continue the next questions.